characteristics one at a time, but we're actually going to start doing the entire second concept, which is graphing as many different rational functions as we can. The steps stay the same for all of them, but the graphs look different every single time. So characteristic one, non-permissible values of x. They will either become wholes or vertical asymptotes. So you look at your non-permissible values. Here's the first example. At x plus 3, x minus 3, x plus 1. So if you have the bottom factored, it's quite easy to see that 3 and minus 1 are not allowed because they cause you to divide by 0. Since they don't cancel out, they will become vertical asymptotes. Anytime you have a non-permissible value that stays in your equation, it becomes a vertical asymptote. If you have a non-permissible value, that cancels out. So in the second example, they're like, this x minus 3 cancels out. Then this equation simplifies to just be x plus 1, but 3 is still a non-permissible value, so you have a whole. So if we want to find the coordinates of that whole, all we have to do is plug in that non-permissible value, because the whole will be at the non-permissible value, in this case, when x is 3. But if you plug that into your new equation, and after this simplifies, my new equation is just x plus 1, well, plugging in 3 into x plus 1 would give me 3, 4. And that's the coordinates of my whole. Also, sometimes wholes are written as a point of discontinuity. Can you figure out why I like to write whole more? No.
I think I can take a shot.
Yeah.
You like saving your time so much that you will not pop a single letter to save off time. So I think saving, how many letters is that?
Too many to count. That would waste time. Yes. That's a lot of work. However, I think there was one year that I just used whole all year, and then on the exam they had point of discontinuity on the exam, and someone was like, what's this? Okay, so it is important. And we call a graph continuous when we can draw it without lifting our pen. As soon as we get to this, we have to lift our pen and start on the other side of the hole, so it causes a discontinuity.
If you shorten the point of discontinuity to POD, you could save even more time.
Oh, a pod. Yes. But I think it might not be. If you talk to other people, they're like, oh, there's a pod. They'd be like, what? Still have the same point of discontinuity.
I mean, we do draw a circle at the top.
Okay. So that's a whole. You find the coordinates of the whole by plugging in the non-permissible value into the simplified equation. And here's an interesting one they have on the next page, where one of these x minus 3's would cancel out. Technically, that should make a whole, but there's still another x minus 3 on the bottom that stays, so then it would stay as a vertical asymptote. So unless that non-permissible value goes away completely, any non-permissible values that are left after you simplified will still be vertical asymptotes. So this one is an example of one that something canceled out, but it didn't make a whole, because you can't have a whole on a vertical asymptote, which is already showing that it's not there. Okay, so we'll go to our first example, and what I'm going to get you to do is get you to write down these steps, because these are the steps, and I'll zoom in here for you. Oh, zoom too much. There we go. Oh, nice. These are the steps that we are going to use for every single graph that we do. We are always going to factor completely. Once you've factored completely, you're going to be able to look at your denominator and list all the non-permissible values. And non-permissible values are going to either be holes or vertical asymptotes. So then you're going to state what your holes are or what your vertical asymptotes are. If there is a hole, that's what the note says in green, you graph the new simplified equation and just add the hole to your graph. Next, we're going to see which group is it. Is the degree bigger in the numerator? Is the degree the same? Or is the degree bigger in the denominator? And that will determine whether we have horizontal asymptotes or oblique asymptotes. And for the oblique asymptotes, we will figure out how to calculate them exactly. So we still have some work to do in this unit. Then we're going to need to, we have all these asymptotes drawn, we're going to need some points. So we're always going to find all of our intercepts, x-intercepts and y-intercepts. And we might find some other nice points as well. And I have in brackets there, 1 point in each section. We'll talk about what that means when we get to it. And finally, once you have some points, you just draw your graph towards your asymptotes, and you will be done. So we start in A. We start by factoring. Step 1, always factor completely first. So we get y equals the top is the difference of squares. X plus 5, x minus 5 over x plus 5. Once it's factored, write down our non-permissible values. X can't equal. So when you write down a non-permissible value, you're allowed to put this slash or the equal sign to say it can't equal minus 5. And we have to decide if that non-permissible value is a hole or a vertical asymptote. So we look, does it simplify? It does. So that tells us we are going to have a hole. And when it simplifies, we get this new equation. And we have a hole at, well, the hole is going to be at the non-permissible value. And now that we've got our simplified equation, we plug that in, we're going to get negative 5, negative 10. In fact, I'm going to take this, no, I'm just going to erase this simplified version. I'm going to actually write it in green. By writing in green, it's going to take us to this note. If there's a hole in your graph, you graph the simplified equation and add the hole. So now to graph this, is this still a rational equation or is this just a line? It's just a line. Since it's just a line, you are no longer graphing this anymore. We can we can skip steps 3, 4, and 5, because this is just a straight line. What do we know about this straight line? We know that it has...
Good thing the question doesn't ask us to graph it, except using graphing.
Yeah, okay. We're going to... Every single question... graph. Because that's the whole purpose of this unit. They want you to do just little bits at a time, but since each graph is slightly different, it's good for us to start right away with the graph. So we're going to get a point, a y-intercept of negative 5, a slope over 1, up 1. You could label your y-intercept. If you wanted to, you could find your x-intercept. And then over here at minus 5, minus 10, we add a hole in our graph. And this question would be done. So again, since the simplified equation is something you knew how to graph, you could graph it right away and just add the hole. So we don't have to do anything with steps 3, 4, and 5. Luckily, in part B, we will. Part B, factor completely. If I can take out a common factor of 2, my non-permissible value, x can't equal 2, whole or vertical asymptote. And this time, it doesn't disappear. Are you okay with the abbreviation V dot A for vertical asymptote? We're going to have a vertical asymptote at, and the equation of a vertical asymptote has an equal sign. So be careful that you're never labeling asymptotes on your graph with the line through. There's a difference between an equation of an asymptote and writing a non-permissible value. The non-permissible value is saying x can't equal 2, which makes an asymptote at x equals 2, because the line always has an equal sign. Okay. So now this time, we have to go to step 3. We have to determine if there's going to be a horizontal asymptote or an oblique asymptote. You notice this is group 2. Degree is the same on the top and the bottom. When the degree was the same on the top and the bottom, was it a horizontal asymptote or oblique asymptote? Horizontal asymptote. Do you remember how to find it? At y equals 4. You look at the highest degree. And you look at the coefficients on the top and the bottom of the highest degree would be 4x over x. It's just 4. We can start graphing this now. So I know that I'm going to have my vertical asymptote at x equals 2, and I know that I have my horizontal asymptote at y equals 4. We just completed step 3. Determine if there's a horizontal asymptote or oblique asymptote. Next, we need to find all the intercepts. The y-intercept is the easiest to find. You just plug in 0 for x. I find the original equation usually the easiest to use for this. Can you see if you plug in 0 for x, you get positive 2 over negative 2. So you get 0, negative 1. To label that point. X-intercepts. X-intercepts, you plug in 0 for y. Sometimes you can have more than one of them. Okay? This is where factoring is really nice as well. Because, and I'm going to just show you here, if I plug 0 in for y, my hope is you never have to do this step often, but you see you could get rid of the fraction by multiplying both sides by x minus 2. And if I did that, I would just get this. Because the bottom would just go away. As a shortcut, does it make sense that the only time, if you have a fraction, the only way a fraction is equal to 0 is if your numerator, the top, is equal to 0. You can't have a fraction equal to 0 in any other way. So I could show this step of multiplying, but it would be fair enough just to look at this and say I can ignore the bottom, because that doesn't matter. I just need the top to equal 0. Can you see that it's going to be negative 1/2? So I go to my graph, negative 1/2, 0. I can label that point as well. That will be the only x-intercept, because that's the only way I can make the top equal to 0. And that's why factoring, it's nice to see. You can see all of your zeros right away. In fact, this is where it says intercepts and nice points. You need 1 point in each section. So now we're going to talk about what did I mean by a section. Every time we have a vertical asymptote, it splits up your domain. So I'm going to call this section to the left of x minus 2 section number 1, and this section number 2. My asymptote broke that up into 2 sections. Do you see that your intercepts were all in section number 1? In fact, we have enough information now. These would join. It's going to go towards the asymptotes. We could graph section 1 already. That's what it's going to look like. But we have no points in section 2. So when it says nice points, really all you're going to do is do a table of values. What could possibly be a point in section 2? Well, I could choose 3 for x. How could I possibly find y? Well, I could go back to my original equation and I could plug in 3. It's going to be 12 plus 2 is 14 on the top, 3 minus 2 is 1 on the bottom. I would have 3 comma 14. Sometimes your nice points won't be the, like, put nice in italicity, because where's 3 comma 14 on this? Oh my goodness. Way up there? Perfect. We could label it. And then we would technically, this continued, you'd have enough to go towards the asymptote there and swoop down towards the asymptote there and you have enough. You could have, if you don't like 3 comma 14, could have plugged in 4. Right? What happens if I plug in 4? I would get 16, 18 divided by 2, I get 4 comma 9. Well, that seems maybe a little bit nicer. I don't know. Estimate where that would be. You just need the 1 point in a section. That was fancy. You just need 1 point in the section because then you can go towards the asymptotes. And your graph is going to be done. So that's what step 4 means when I say 1 point in each section. Sometimes your x-intercepts and y-intercepts will be enough and you don't have to do any other points. But in this case, we needed 1 extra nice point to figure it out. There are some graphs that you need multiple extra points before you can figure it out, because there's not enough information. But once you've got enough points, then you just draw your graph towards your asymptotes, and you're done. Okay, questions for practice on this one? Just number 5.